Yep. We're back again. Here is part 3 of the lesson we'll be going in. Increasing, decreasing function and the first derivative test. Today we'll be going over the first derivative test. So, ready? There is no do now because technically you did it last lesson. So, let's look at this. Theorem 4.6, the first derivative test. Let C be a critical number of a function that is continuous on an open interval I containing C. If f is differentiable on that interval except possibly at C, then f of C can be classified as the following. 3 things. First derivative test tells you 3 things. Number 1, is it a relative minimum? So that's if f of x, right here, it changes from negative to positive. All right? Negative slopes go down, positive slopes go up. Oh, jumped the gun on positive, okay? So if you go from a negative slope to a positive slope, you have a minimum. Pretty obvious. So you have a maximum when you yell it out. You go from a, where we at? Oh, this is like a valley. Sorry, like if you're in the mountains, the valley you're in, fill up with water if you pour a glass into it. All right, so this one goes from a positive to a negative. All right, f of x is greater than 0 is obviously positive, less than 0, negative. Didn't think you need to know that, but if you want to, you can. So this isn't like a valley. This is the opposite of valley, which is a, where is the P? E, A, peak. Now you have the third choice. It's neither relative minimum or a relative maximum. Now, if f prime x is doing, what is it doing here on both sides? Positive on both sides because you got 2 positives, increasing, they're both greater than 0. Or it's not a maximum min if it is opposite of positive, negative on both sides. So that is a negative and a negative. It is less than 0. So if it decreases, levels off and decreases again. So you can have situations where it's neither positive nor negative. Got it? Now, let's apply it with problem number 12. Now, f of x equals 1/2 x minus sine x on the interval from 0 to 2 pi. So we're going to find the relative extrema of the function. So first thing I want you guys to do is derive this equation right here. Yes, can I help you? You can help if you like. Derivative of 1/2 x is 1/2. Derivative of negative sine is minus cosine x. Or to solve for xu, add cosine to both sides. You get cosine x equals 1/2. So when does cosine x equals 1/2? This is the cosine curve, so it equals 1/2 here and here. All right? That's at pi over 3, and that's at 5 pi over 3. Now, not everyone could do this in their head. You can use the unit circle 1, or you can also use, in the back of your books, there's a page that actually tells you all the different things cosine x equals. It says all the things they equal, and then it tells you what x would be. All right? Anyway, these are my 2 critical numbers, so they go in my 2 boxes. Why did I put these numbers like this? Well, this is what 2 pi is as a decimal. This is what this is as a decimal, and this is what this is as a decimal. All right, now the decimals are a little bit better because what they do is they help you just find the intervals better. Anyway, if I plug in a 1 into here, I get negative 0.4. If I plug a 2, which is between these 2, in between the 2, you get 0.92. And between these 2, I guess you could have like a 5.5, a 6. All right? You get negative 0.46. So, if you look at your graph right here, you can see it goes down, goes up, and then it goes back down. Now, the way you should have filled out your chart, if you did that, pi over 3. This is my 5 pi over 3. 0 to pi over 3, pi over 3 to 5 pi over 3. Same, you can use numbers too. All right? We said this one, our test value was 1, right? And we got negative 0.04. This test value is 2, which is a negative, which is decreasing. This one right here, we used our test value between these 2 is 2. We found our answer to be 0.92. Positive number increasing. And then here, we use 6. Plugged it in, all into the derivative. Negative number, which is decreasing. All right, all nice and easy. Got it? Awesome. Now, here's the table I was talking about before. So if you look right here, 1/2. So you look at the table, and you go, okay, cosine is 1/2, so I go for about 0.5. 0.5. That's 60 degrees. All right? 60 degrees, you would then go to your unit circle and say, where is 60 degrees at? 60 degrees happens to be both of them. All right? There it is right there. Got it? So this is a table you would use, then you convert the angles to the other stuff. We don't really have to worry about that in here, but it's something you'll see in college. I would like you guys to try problem 13. All right, you should be done. You have to use the chain rule to derive this. U, f of u. X squared minus 4 and u to the 2/3. 2x minus 0. 2/3 u to the 2/3 minus 1 is a negative 1/3. All right, multiply these two together. 2x times 2/3 is 4x over 3. All right, and then you plug your u back in for u. Now, this is raised to a power, just so you know. Now, what you want to do is you're going to set this equal to 0. But before you do that, you want to rewrite it. Negative 1/3 means this goes on the bottom, and it is a cubed root. That's why I made it green. All right? We got to set it equal to 0, set it equal to undefined. So, first off, when it's 0, the numerator equals 0. So when it's 4x equals 0, when x is 0. Now, when you make this undefined, you set the denominator equal to 0. 3 times cubed root of x squared minus 4. Divide both sides by 3. Cube both sides. 0 stays the same and all this. Now add 4. And the square root of 4 is a plus or minus 2. So you have 1, 2, 3 critical numbers, and that's where they go. Negative 2 is the smallest. 0 is the middle. And then 2 is here. Now what you're going to do is you're going to create your intervals. Between these two is negative infinity to negative 2. I just used the one we used to use with domain and range because that's a little nicer than putting the x greater than, less than, I think. Negative 2 to 0, 0 to 2, 0 to 2, and 2 to infinity. All right, once you got these set up, test value number between those two, negative 3. Now, I don't even care what the actual answer is. When I type negative 3 in here, I get negative 12 over 9 minus 4 is 5. So 3 times the cubed root of 5 is some positive number. The key here is a negative over a positive is a negative. Negative numbers are decreasing. Once again, number doesn't matter. All that matters is the sign. Type in negative 1. Negative 4 over another negative. All right, because this becomes a negative number right here. Negative over negative is indeed positive. Increasing. All right. 1. 1 over some type of negative number. Positive over negative is a negative. It is decreasing. And then finally right here you got 3. Positive over positive is a positive number, which means your graph is increasing. All right? All good? Awesome. Number 14. Find the relative extrema of x to the 4th plus 1 over x squared. So what you guys should have been doing here was you should have used your quotient rule. So I'll give you a little time to do that if you haven't done it yet. Once again, you hit the pause button, slow me down. F is your numerator, x to the 4th plus 1. G is your denominator, x squared. All right, so derivative of this is 4x to the 3rd. All right, derivative of x squared is 2x. F prime times g, g prime times f. 4x cubed times x squared is actually 4x to the 5th. Negative 2x squared times x to the 4th is negative 2x to the 5th. Negative 2x times 1 is negative 2x. All right? Subtract these two numbers, combine like terms, you get 2x to the 5th minus 2x over x to the 4th. All right? Not too bad yet. So what you're going to do is you're going to take the numerator, set that equal to 0. That's when your whole example is 0, your numerator is 0. You are going to take a 2x out, set the first piece equal to 0, set the second piece equal to 0. So divide both sides by 2, x is 0. X to the 4th minus 1 equals 0. Add 1 to both sides. What to the 4th power equals 1, but a positive and a negative 1. So you have 1, 2, 3 critical points. All right, now you also set the denominator equal to 0. All right, when you set that equals 0, x to the 4th is 0, x is 0. Notice, same number, so same critical point, so you still only have 1, 2, 3 critical points. Let's go in order. Smallest number of all these is a negative 1. Then you have 0, and then you have positive 1. Negative infinity to negative 1 is my first. Negative 1 to 0, and then 0 to 1, and 1 to infinity. Pick your test numbers between each one of these intervals as you did before. -2 is a good one. When you plug it into this equation right here, you get -3.75, which is a negative number, which means your graph is going to be going down. All right, take a number between these two, like 0.5, plug it in here. All right, make sure you type it in your calculator correctly. You get 1, which is a positive number, which is increasing. So you're going to be decreasing and then increasing. Number between these, this was the -0.5, so pick a positive 0.5. Type it in here, you get -1 as an answer, negative number, which means your graph is decreasing. 2, you get 3.75, which is a positive number, which is also increasing. So your graph is going to go down, and up. All right, there's also a asymptote at 0. So at 0, there's actually no extrema. It's just a vertical asymptote. All right, now what I want you guys to do for 15 and 16 is find the example. All right, find the critical number. Also find the critical point. So do that for the first step. Good. So to find the critical number, you derive that. You get 2x minus 4. You add 4 to both sides, divide by 2, and you get x equals 2. Now to find the critical point, you're going to take that 2 and plug it into your original equation, because this is your x value, you need your y value. 2 squared minus 4 times 2, 4 minus 8 is -4. All right? So your actual extrema, your maximum or your minimum point, is 2, -4. Now that we got the actual point, we can find out what it's doing on both sides of this point. So you set up your intervals from -infinity to your critical number, which is 2, and from 2 to, positive infinity. Pick a test number. Hopefully you picked a number. I picked an easy number like 0. When I plug 0 into my derivative, 0 minus 4 is -4. Negative numbers mean my graph is decreasing. Then you pick a number between here. I picked 3. I don't know what you picked. 2 times 3 minus 4. 6 minus 4 is 2. 2 is a positive number. Positive numbers increase. If I picked a number like 5, 2 times 5 is 10. 10 minus 4 is 6. 6 is still positive. It's still increasing. Any number you pick between these two is going to be positive, making it increase. And this is actually a parabola. It goes down, hits this point, and goes back up. All right, so try problem 16. Same concept that we did here. Good. 2x plus 6 equals 0. Subtract 6 from both sides. 2 is -6. Divide by 2 and x equals -3. All right? Take -3. Plug it into that equation. You get -17. So our extrema, our max midpoint, is -3 and -17. Also, since this goes from decreasing to increasing, tells us that's a minimum. So, critical numbers, -infinity to -3, -3 to positive infinity. Pick a number between these two. It's not 0, because 0 is actually here. It's like -4. -8 plus 6 is -2. Negative number, once again, decreasing. Good number here is 0. 0 plus 6 is 6. If you pick 1, 2 plus 6 is 8. If you pick -2. -4 plus 6 is 2. All cases are positive. It means it's increasing. So you're going to decrease, increasing, meaning this point right here is a minimum. All right? Good. Once you do 17, 18, the same exact way. All right? Let's go over them real quick. Derivative of that, 4x plus 4. Add 4 to both sides. Subtract 4 to both sides. Divide both sides by -4. X is positive 1. Take the 1, plug it into the equation to get your extrema. You get 5, so your point is 1, 5. Extremas are points, remember. Now you take your critical number, -infinity to 1, and 1 to infinity. Number between these, good number is 0. 0 plus 4 is 4. Positive number, which is increasing. Let's go 2. -8 plus 4 is -4. Negative number decreasing. So this graph actually goes up, and then it goes back down. It goes up to 1, 5, and then it goes back down. All right? Right here. Distribute that negative first. -x squared minus 8 minus 12. Now you derive it. -2x plus, minus 8 minus 0 equals 0. Add 8. Divide by -2. X equals -4. Take that -4, plug it into either one of these equations. I plug in the top one. 16 minus 32. Plus 12, a negative answer. So it's a -4, which is a positive 4. So your extrema point is -4, positive 4. All right, one critical number means we go from, once again, correct, -infinity to 4, -4, -4 to infinity. Number between these two, -5. 10 minus 8 is Positive 2. Positive 2 means the graph's going up. Let's go with the 0. 0 is always a good one. Negative 8. Negative number decreasing. So the graph goes up, hits the maxima, relative maxima, negative 4, 4, and then it goes back down. Got it? Awesome. All right, let's finish up with 19 and 20. You do not have to find the points. So this one, just find the critical numbers. After you find the critical numbers, find the intervals where they're increasing, decreasing, and then find the, that's it. All right, should be done. Derive 6x squared plus 6x minus 12 equals 0. Now we can use that rule that we did. No, you don't have to. You can just take a 6 out. If you divide everything by 6, this becomes 1, 1, negative 2. 0 divided by 6 is 0. Now this is easy factoring. X plus 2, x minus 1. Set them both equal to 0. X plus 2 equals 0. X equals negative 2. X minus 1 equals 0. X equals 1. All right? So you got from negative infinity to negative 2, negative 2 to 1, and from 1 to infinity. Number between these two is negative 3. That's okay. Goes 24. 24 is a positive number. Positive numbers increase. Right here, good number is 0. Put 0 in there, you get negative 12. Negative 12 is a negative number. They decrease. 2. 24. 24 is a positive number, which means your graph is increasing. All right? So your graph's going to go up, down, and up. And you can plug these in to find the actual points if you want. We just know how to do that already, so it's just overkill at this point. Problem number 20. Derive 3x squared minus 6 equals 0. Add 6. Divide by 3. X squared equals 2. So take the square root. X equals negative radical 2. And also radical 2, or a plus minus. That's also a plus minus 1.41. Negative infinity to negative radical 2. Negative radical 2 to radical 2. And radical 2 to infinity. If you prefer to use fractions, you may. Negative 2. Plug that into this equation. 3 times 4 minus 6 is 6. 6 is a positive number. Positive number means my graph is increasing. Good number between those two is 0. 0 minus 6 is a negative 6, which is a negative number, which means my graph is decreasing. What do we want to pick here? 2. 2 times 4. 3 times 4 is 12. Minus 6 is 6. Positive number, increasing. So our graph goes up, down, up. All right? Any questions with, this equation?